Okay, continuing on now with the properties in trigonometry. Here is I've just written up while we were queuing up this segment, I wrote up here some of these reciprocal identities, is the way we speak of them. And you just need to, and I went over this on a previous session, but you need to kind of commit these to memory as well. The reciprocal of the sine function. The reciprocal of the sine function is called the cosecant function. Or you could flip those upside down through the algebra process. The sine function then is going to be the reciprocal of the cosecant function. Similarly, the reciprocal of the cosine function is the secant function. And this is in any trigonometry textbook. And the reciprocal, then if you do the algebra here to turn these over, find their reciprocals, the cosine function is then going to be the reciprocal of the secant function. And finally, the cotangent function is the reciprocal of the tangent function. And so therefore then the tangent function is the reciprocal of the cotangent. All right, now back to the x, y, and r values, which we were showing earlier, x, y, and r. You know that the sine of an angle, and these are the ones, as I keep saying, that you want to have in your head is the sine, cosine, and tangent. You know the sine is y over r. Y over r. So if you take the reciprocal of that, you're going to get r over y. Similarly, if you take the cosine reading of the angle being x over r, its reciprocal is r over x. And you also know that the tangent is y over x. Its reciprocal then is going to be x over y. So you want to commit this stuff to memory. While you're jotting those down, I'm going to see what other items might be here that are important for us to have available. I've already done this with you. The tangent of an angle is the sine of the angle over the cosine of the angle. That's as well very important. And when you start applying trig in practical ways, there are a couple other theorems that are really important. And I want to give those to you. And it's actually something you remember from pre-algebra even, many of you, or beginning algebra, with a little bit of embellishment. If we take our unit circle, once again, you're going to keep seeing this and you're going to keep drawing it yourself with a standard angle shown, and I could place it anywhere. It's easiest to place it in the first quadrant. You know that the y reading here is the sine of that angle, and you know that this x reading down here is the cosine of that angle. Now, what is it from your beginning algebra background that you can see is a relationship between those three sides? The two legs and the hypotenuse. Well, they're positive in this case, in the first quadrant, yes. Who's that guy that lived a long, long time ago? Pythagoras. We love Pythagoras. Great guy. Right? Yes. Thank you. You square the legs, and you add the squares of the legs together, and you get the hypotenuse squared. So the sine of the angle squared, you're squaring the ratio. You're not squaring the angle. Notice the parentheses I wrote down there. You're squaring the ratio, not the angle. It wouldn't make any sense to square 30 degrees, would it? Okay. No, it doesn't make much sense. So what we're doing is we're squaring the ratio reading here. And then we're adding to it the square of the other leg, which is a ratio as well, and that's equal to 1 squared, 1. Mathematicians are notorious for writing shorthand. So the way we write this, instead of having to put all those parentheses in there, is we typically write this down this way. That's called the Pythagorean identity. Easy. Leg, hypotenuse squared. The hypotenuse on that right triangle is 1. Square it. Okay. Got it? Now, watch this. You're going to like this, and I only have about a minute or so left because I'm running out of time. I can't get this segmenting properly done into about 20-minute segments. So what if I divided both sides of this identity by sine squared? If I divide this by sine squared, it turns to 1. If I divide this by sine squared, I have cosine over sine being squared, don't I? And that is cosine over sine. It's right up here on the board behind me. Cotangent, right? Sine over cosine is tangent. Cosine over sine is cotangent, right? So I get the cotangent of the angle being squared. And that's equal to 1 over sine squared. And 1 over sine of an angle is cosecant. So this is equal to cosecant squared of theta. Very simple beginning algebra. And finally, to close this, since I'm out of time, is what if I divide both sides of the Pythagorean identity here by cosine squared? If I divide both sides by cosine squared here, I get tangent squared of the angle plus 1 is equal to 1 over the cosine squared.
Secant squared.
Good. 1 over cosine is secant, and so I get the secant squared of the angle, or secant of the angle squared. Okay, so these are called
both those things you just wrote we need.
Yeah, you know, after all these years, folks, I know this first one, like my phone number or my name, but these two, even after all these years, I don't have these memorized. I just mentally think of them when I need them. Okay, so that'll wrap it up today. We'll practice some with the properties and continue on tomorrow. Don't forget, 11 o'clock to 12 here tomorrow. Here, tomorrow. Here, yes. Good. Yeah.